Alright, so we were covering the topic of this internal rate of return related examples, and I was just explaining you how this is a slightly different form of a calculation compared to what you have been doing so far. In your all previous examples, you had a minimum expectation rate of return, whatever MARR value, and accordingly you calculated present worth and annual worth and future worth and made a decision. But here I am asking is, independent of MARR, what is the only the characteristic of the cash flow series, what is the rate of return that is coming out of it. So we get that value by equating the present worth formula or the annual worth series, whatever you can for a particular cash flow, and you equate it to 0 to estimate the I percentage, or I am calling that as I star percentage just to make things little bit distinguished. And I was explaining you about this two types of method. One is this trial and error method, and I also recommended to go with this graphical way of estimating IRR. So in trial and error, what was the main idea is that if your present worth is a function of, let's say, your income and then some function of the interest rate, some polynomial, let's say, and then you have cost and some function of polynomial, let's say I, right? So the idea is pretty intuitive according to where to move when you are doing the analysis by trial and error. So what happens is, suppose you assume a value of I star and you estimate the present worth on that particular I star. If that present worth at a particular I star that you have assumed is coming out to be positive, it means the income term is stronger compared to the cost term. So then in order to make the fraction go to 0 or this expression go to 0, you need to reduce the power of the income term, right? Therefore, the I should be increased so that you will reach to that kind of a goal, right? If in any situation you get I star at a particular I star assumed value of I star, you get a PW less than 0, it means that the cost term is much stronger, right? So you need to reduce the power of the cost term. How do you reduce the power of the cost term? Is by again decreasing the I value, right? So this can give you an idea of which direction to move. Another way to look at it is generally the graphical way of NPV versus NPV versus the rate looks such kind of a profile. So when you are approaching 0, if you are having a positive value at any assumed I, it means you have to go slightly forward. If you are getting an NPV of negative at a particular I, it means you have to slightly go behind, right? In order to estimate the where exactly is NPV equal to 0, right? This is the intuition worthy, but I was also explaining you some of the problems with this kind of an approach. In general, Excel also has an IRR formula, but best is to plot the graphical representation of NPV versus I. Once you know the distribution, all you need to estimate is the typical values where the curves crosses the horizontal line. That will be the I value which will be satisfying the equation, right? Now what happens in the real world is, because it's an n order polynomial, this curve can behave very randomly. It can have multiple routes, multiple locations at which it crosses the horizontal line NPV equals to 0 line, and therefore you have to be careful. So what are some of the ideas? For example, let's say in this particular case, this I value is coming out to be somewhere about 80%. So then you have to make a judgment whether it is realistic to expect a 80% return from a particular project. If any project, such project exists in the world, will you be having the opportunity to invest in it? Kind of the question. So it's like basically it's a very unrealistic number, although it satisfies the equation. It's not what you are expecting or what is a realistic expectation. Therefore, you can ignore certain solutions of this kind of a space, right? So that's the idea. So you need to put such kind of subjective criteria to then define what is the acceptable I percent value for you or I star value for you, right? So the easiest to avoid the hassle, if nothing is given, if nothing is mentioned that you must do only by IRR method, do not go for IRR method. Go for simple, get a value of MARR, what is your minimum acceptable rate of return, calculate the present worth or annual worth at that MARR and make a judgment whether a particular alternative is making sense to you or not, right? IRR is very intuitive. A lot of people will ask you to do so, but not the best method because it has certain complications. But the present worth analysis is straightforward. We have already seen the analysis that way. Okay? Clear? Any questions in this part so far? Alright. So, this particular method so far we have seen only for one project. IRR for one project versus IRR for second project versus IRR for third project. So, how do you use the IRR method to compare the alternatives? Because in present worth, that's what we have been doing, right? Present worth of a single project does not make sense. You have to ultimately be able to compare multiple projects. So, how do you compare multiple projects using the IRR method is what I am going to show you, right? What happens is, so suppose you consider an example, let's say an investment of 100 rupee returns you total 200 rupees at the end of year 1. So, your rate of return on this particular case is 100%, right? But your absolute amount of money that you are making on this profit is just 100 rupees, right? But on the alternative, let's say you could have invested 10,000 rupees and you are getting only 12,000 rupees. So, your of course rate of return for this is just 20%. But the absolute amount of profit that you are generating is 2,000 rupees. So, if you had the paying capacity of 10,000 rupees where you could maximize your absolute amount of profit, why not go for second option even though the ROR or the first option is much higher compared to the second option, right? So, because we are talking about mutually exclusive projects, that once you invest in one particular project, you are automatically debarred from investing in any other. So, you are always asking for one best alternative. So, what if you pay slightly higher money, some project which costs slightly higher, but your return is also higher compared to that? Would you go make an investment in that or not is the key question that you can answer using this kind of a method, right? So, suppose you have 100 rupees in total. I give you two options, 40 rupees and a 60 rupee project. The extra cost of 20 rupees, is it worth? Is it worth investing in that extra 20 rupees or are you satisfied only with the 40 rupees alternative is the question that you can actually answer using that, right? So, if one alternative requires a higher initial investment than the other, an evaluation is needed on the ROR on something called the incremental of the initial investment. And this concept you have already kind of understood in the assignment 1, but let me repeat it for you. This is basically called incremental rate of return. So, what I am saying is, let's say there is a cash flow series of the current alternative and there is a cash flow series of alternative 2 which costs slightly higher. So, if you take the difference of alternative 2 versus alternative 1 in the cash flow, you will see how much extra revenue you are generating for the extra cost, the incremental extra cost that you have put, right? So, once you have generated such incremental cash flow series, you can also make a judgment whether that increment is actually beneficial for you or not. Let me give you an example. So, this is essentially called a concept called incremental rate of return. So, when the best alternative is to be selected from two or more mutually exclusive alternatives on the basis of rate of return analysis, this particular method is useful. It's called IROR, another complication in your life, but IROR it's called, right? In this method, the alternative is the larger investment is selected, given that the incremental or the extra investment that you are making in order to reach to the high cost alternative produces a rate of return that is at least greater or equal to your MARR, right? So, let's say what I am saying is, you have two alternatives. One has some 40,000 rupees, it has some cash flow series. Another takes 60,000 rupees, but it has some slightly higher cash flow series. So, when you take the difference of the two, it becomes to be 20,000 rupees and some difference between two of these annual value. This I am calling as the incremental cash flow series. Now, this cash flow series is justifiable if at MARR the present worth of this incremental cash flow series is greater than 0. If that happens, only then it makes sense for you to invest in that. Otherwise, your money is as good as you are investing in here and the rest of the money is actually getting you MARR. That's the kind of assumption you have, right? Let me again give you a more detailed examples of what is happening to your actual money. Suppose you have total 100,000 rupees. In a mutually exclusive project, when you invest in one amount, let's say you invested 40,000 in this project, what happens to the remaining 60,000? Any idea? Yeah, so the assumption is that this particular money is invested at least at MARR level, right? So, if you are investing 40,000, for the remaining at least 60,000 is there. That's why you are making the decision to invest in 40,000 also, right? Because it is giving you returns at least higher than MARR. So, the same logic apply. Now that you want to put another 20,000 in this bucket, that 20,000 should generate at least MARR, otherwise you are better off choosing for the lower cost alternative, right? Making sense? So, yeah, so if an alternative requires a higher initial investment than the other and the evaluation is on the rate of return, the increment of initial investment, the return yielded on this extra investment is called incremental rate of return. So, the cash flow series, once you have gotten this incremental cash flow series, now you calculate I star of this incremental cash flow series. That is essentially your incremental rate of return. Confused? Too many terms? I'm not doing simply. I'm subtracting one cash flow series from another, and the net cash flow series that you've gotten, I'm calculating the I star, which is the rate of return of this net cash flow series, and I'm calling that as IROR, which is the incremental rate of return. So I have both ways to explain you, simple and the more logical, which is the more formal definition of the same thing. But clear? Let me give you more examples. Okay. So, of course, these assumptions hold true. So, the analysis makes the assumption that sufficient funds are available to finance the alternative with the highest investment, right? So, if one alternative is costing you 40,000, another one is costing you 80,000, you should have at least 80,000 rupees. Otherwise, this analysis makes no sense, right? If one of the lower cost alternative is selected, the excess fund, that is the difference in cost between the lower cost alternative and the higher cost alternative, is assumed to be invested somewhere else, and that is earning at least your minimum acceptable rate of return, right? That's assumption. Based on that, we have calculated. So, essentially, the MARR provides you over the range of funds available. It kinds of give you the maximum optimal answer for that, right? That's the ultimate goal for you as an investor, that you are trying to maximize your overall portfolio, and that's what the criteria is actually coming out on how to select a particular project. All right. First is, you have to list out all the alternatives in ascending order of their first cost. So what you do, let's say you have 4 alternatives. What you simply do is you rearrange them, and just calling them, basically numbering of them is slightly different, and you arrange them in ascending order of increasing cost, so that the first alternative is the lowest cost, then the second highest cost, third highest cost, and the fourth highest cost, and like that you can actually put. Now, what I'm doing is compare the rate of return of all the alternatives with the assumed MARR and check if the rate of return is at least equal to MARR. So what is happening? Let's say I have some alternatives. After the step 1, I have rearranged them in this manner, right? Now, before you go on comparing the alternatives, the first criteria is whether individual of these projects are making sense or not, right? If one of them is a loss-making analysis or the alternative, why even bother compare it with multiple alternatives? So, the cash flow series of all these A, B, C, D, based on that, you can estimate their I star values, right? If these I star values, any of these I star values less than your demand, less than what your minimum expectation is, you immediately eliminate that option from comparison because there is no point taking it further, right? So suppose after the step 2, you have remained with the option D gets eliminated, right? Now, what you are doing is prepare the cash flow series in incremental basis. So what do I mean by incremental basis? First, I will compare A and C. So I'll prepare a cash flow series which is a difference of C and, like basically cash flow series of C minus cash flow series of A. Then cash flow series of B minus cash flow series of C, or whatever happens, right? Basically that's what I'm doing in incremental series. This is a very interesting term, something called a challenger and defender. In this concept, just I'm introducing. Later this becomes more formal. We will need this definition more formally. But essentially, the defender is the current alternative with least cost. It's trying to defend its position of becoming the best alternative. And the challenger is the next higher cost alternative, which is trying to challenge its position for becoming the best alternative, right? So when A is the least cost, in the first step, A is your defender. It's essentially trying to become the best. Every alternative wants to win and every alternative wants to become the best alternative. So currently A is your defender and it is challenged by C. So you do analysis between C and A. If challenger wins, the challenger becomes the next defender because now it will get a challenge from the next alternative. If the defender wins, challenger goes out, defender competes with the another challenger, right? Simple. Essentially what you are trying to do is compare each alternative with every of the other alternatives, and in each comparison you are eliminating one option, right? Simple. It's in a normal method, it is very simple. It's just when you complicate things by defender, challenger, a formal 6 pages definition of the thing, it becomes complicated. But essentially you have to first eliminate all the options which are not making any financial sense independently. Then you start making the incremental series. In a pairwise comparison, you eliminate one option, then take the winner of this to next comparison. Similarly, you find out the best alternative, right? All right. So now let me give you more details in terms of what is happening when you are comparing an incremental cash flow. Suppose the match 1 between A, C, what is happening between a first match of A and C, what are you exactly doing, right? So you actually make a cash flow diagram on an incremental basis and you calculate of that incremental cash flow series, you calculate the rate of return, which is the basically NPV of that incremental series, you equate it to 0 to calculate the incremental rate of return. Let's look at an example here. So cash flow, this is for project A, B, all this is only cost. This is some cost plus profit is also there. So first question, can you even do the IRR analysis of first? No. For second, can you do an IRR analysis? You can do, theoretically you can do. Still, for comparison, even though you cannot use IRR analysis for only the cash flow series A, it is possible that you may be able to do an IRR analysis on the incremental series, which is the difference of the two series. Because the difference of the two series could be resulting into a net positive cash flow for some combination, right? So even though you are not able to do the first step in this particular case, it does not stop you from comparing the alternatives, right? So what is happening is the first 1-2 step is not applicable here for cash flow series A, but you can still do a comparative assessment whether it makes sense to invest in B compared to A. That you can still do using the IRR method. Okay. So what's happening here? Let's look into the details of it. So alternative A is basically $8,000, but it has some annual maintenance cost cash flow series, and then alternative B costs slightly higher, $5,000 extra, and then it generates some $500 annually in terms of some profit. So the incremental cash flow series becomes B minus A, which is minus 5,000, the extra cost that it took to take project B, but the additional revenue that you generate because of taking of the project B. Clear how we have calculated incremental cash flows? At each point of time, you basically subtract one from the other. You have to define basically, subtraction is always, again, sign might reverse depending upon which area which you are comparing from, but you have to be careful about that, right? So now this series seems like a more profitable series, and you can easily estimate the I star value of this, and that will be your incremental rate of return. Clear? So far the steps clear in terms of how are we planning to do. Next is, when an alternative which has just been examined, so for example, one match between A and B has happened and you have a winner that out of A and B, B wins the case. So then if B wins the case, it becomes the new defender and it basically will challenge the other alternatives. If B loses, A continues to be the defender and it will start challenging the next alternative that is available. You finish this analysis till you have a final clear winner of all the cases, and that will be your one best alternative, right? Yeah, and the criteria of who wins the match between A and B is whether the incremental rate of return that you have gotten is at least greater than equal to your minimum acceptable rate of return. Making sense? The same logic persists. If the cash flow series of the incremental cash flow series that is giving you rate of return at least higher than your minimum, whatever the required rate of return is, it means it makes sense for you to go to a higher alternative, higher cost alternative, and you will move to that, and then you will compare the next one, right? Let's take an example and do it properly, okay? So let's say there is a project X and Y. Initially, both of them are of the same cost. So here, so the concept of defender challenger, you don't have to rigorously follow, okay? That's just for you to give a more systematic way. I will never put a point on you that no, this is the defender in this case. It's basically relative. Ultimately, you have to compare whatever is the net difference of the increment series. That's what you have to estimate. So in this case, X and Y, let's say original cost for both of them was 50,000, 50,000. But the X generated 5,000, 17,500, 13,000 and 42,000 cash flow series, and Y generated. So what I am saying is, I want to know whether X is more better compared to Y. So whether X is better compared to Y, so I will get the incremental cash flow series of X minus Y, right? And I have given you my acceptable rate of return is 10%. Alright, so your net cash flow series of XY becomes year 0, the net is 0, year 1, the net is 35,000 down, year 2, 3, 4, this becomes the net values. Agree? Right? Now, can you calculate the cash flow, can you calculate the I star value for this series using trial and error? Can you try? I'll give you a hint. Start with 10% and then you can take the increment wherever you want to. Tell me what is the present worth when you put I equals to 10% of this incremental cash flow series. What is the present worth at I 10%? 300. Option A. What is option B? Minus 40 point 10% present worth of this expression. 300 point. Anyone else? Any other options? 305. 305. Not 300.5. 305. So option C is 305. so easy to generate options in this class. Just ask people to solve the question. 305, 300.5. So you are eliminating option C. Okay. You're sure about minus 40? Sure? 100% sure? See, 300 and 305 will not become so much of a blunder in this particular case, because at least your direction of next increment is consistent. You know that it is a high value, so you need to increase the I in order to reach somewhere which is a target. But if you start with a minus 40 in this case, you will move the opposite direction, right? And then it's, of course, you might still converge to the answer, but you will actually have a more calculation steps required. So what is it? 300 or 40 minus 41? Check your calculation. Now it's correct. So it's 300.4. Now assume 15% present worth of the same series at I is equals to 15%. Minus 2958.47. Option A or is option B? Minus 2958 matching, right? So now you have one value at which the NPV is positive and you have one value at which NPV is negative. So the solution has to be somewhere, at least one solution has to be somewhere between. So what you do is linear interpolation. What's the answer? You have 10, 300.5, 15, minus 2958. What is the value at which NPV equals to 0? What is the I star of this incremental cash flow series? 10.46%. Anyone else? Same? Everyone is getting same? Right. So, yeah, theoretically, all of you are, at least I'm liking that there are not so many options getting generated nowadays. So, all of you are converging to the right set of answers. So, and now 10.46 is greater than your minimum acceptable rate of return, MARR. So, it means you should prefer option X over option Y. Now, here's the trick. If somebody actually does not ask you what is the incremental rate of return, just to make a decision whether X is preferable over Y, you don't need to do the whole calculation. Just the first calculation, when you know your MARR value, you calculated present worth on MARR, it's giving you a positive value. It means that actual I star would be higher than your MARR. It means your decision is already clear that X will be preferable over Y in this particular case, right? So you don't need to actually do the calculation to make this decision. If the question is only about the decision, if it's a quick question, you can still make the decision immediately. One of your fundamental assumption in that case is that your series is behaving like this. In this class, it will behave like this. In real world, it will not behave like this. Okay. So if under this assumption, you could have saved some time of your calculation if the question is only asking you about the decision, not the absolute value of your incremental rate of return. If that is not the question, you can still make the decision very easily. So a rule of thumb, always start with your MARR as the first guess of your calculation when you have to estimate the rate of return. Always start at MARR. You will be immediately able to make a judgment whether it is making sense or not, right? And then you take the increment. So the first gap has to be at MARR level. Alright, if MARR is given. If not, then you can curse me. Alright, so let's look at a little bit more detailed example. So say a development authority of a city has to select a pumping unit from 4 feasible mutually exclusive alternatives for supply of water to a particular location, right? The details of the cash flow series and useful life of all these things are given. The minimum attractive rate of return, the MARR, is 20% per year. Select the best alternative using the incremental investment interest rate of return analysis. This should be interest rate of return analysis. One very important thing, can you do this analysis if the lives of different alternatives are not same? Yes. So in that case, you have to take LCM because ultimately it's an incremental series and that can be only calculated for each time period. The increment has to be calculated each time period. So you have to make the total time uniform, right? So there is no, if the alternatives are of different lives, you need to take LCM and then you need to start the incremental cash flow series calculation. Alright, so let's look at this example, A1, A2, A3, A4. Initial capital investment is given to you. So what will be the ordering? What will be your first defender? A2 becomes your first, then A1, A3 and A4, right? Now what's the first step? Before even I go to alternatives, since these are positive cash flow series, you can actually first calculate whether individually each of these investments are giving you at least MARR, right? So this is, oh, I have not done that here. Alright, so I have already given you a, no, it's the same. So far, we have just rearranged them a little bit. Now you calculate, immediately I am going on to the comparative, but ideally you should first do the check whether each of these alternatives is actually making sense or not. But actually it might not, because all of them are mostly cost heavy alternatives, right? So 22,000, 6,000, 2,000 rupees as a salvage value at the end of 10 years, most likely you will not get an MRR, and all of these are essentially following the same set of criteria. So these are all cost kind of alternative. So therefore that step does not make any sense. So you immediately go on comparison. So now you are comparing A2 versus A1. Now again you could argue, sir, A1 is my challenger, I will subtract A1 from A2 or A2 from A1. If you subtract A1 from A2, you will not get a good series. Basically then you will have to again take a difference of minus, because the cash flow series, net cash flow series is kind of on a positive, negative side. So make your life convenient. Do not get stuck to the combinations that I have given to you. Ultimately aim is to compare all the alternatives. Do not get stuck in the terminology of challenger and defender and the order of challenger and defender and things like that, right? It's just to give you some logical way. If a computer program has to be written, that's how it has to be written, okay? Now let's say compare, I say that I am preferring A2 over A1, so I am getting an incremental series of A2 minus A1. So that comes out to be what? What is A2 minus A1? The first value would be what? 8,000 rupees positive. And then 2,000 rupees positive. And then a salvage value negative 1,000, right? So this becomes your cash flow series. Now you calculate the rate for this, which will be IROR, which is the incremental rate of return, and that has to be at least greater than MARR. So if you do that, assume I equals to 15. Ideally you should have assumed I equal to 20 and then immediately get an answer. You assume I is equals to 15, you will get this particular value. You assume I equals to 20%, you will get this particular value. Again, we are not reaching anything basically substantial. You have still not gotten the one positive and one negative value, but you could make a judgment, because even at 20%, the value of this incremental cash flow present worth is coming out to be positive. It means the actual IRR is higher than the 20%, which is your minimum acceptable. It means no matter what you do, it's going to be preferable alternative. So A2 is preferred over A1, right? So ideally you should have always start with your MARR if it is given, so that your decision becomes faster. Because your question is not about calculating IROR of each of the steps. Your question is about which alternative is the best alternative. Alright. Now, A2 win in the A2 versus A1 game. So then I move to the next alternative, which is the A2 minus A4. You draw the cash flow series. Again, you will find that A2 wins. And similarly, you finally do a match of A2 versus A3. And you will find again A2 will win over A3, right? So you can actually make this kind of a table. So in A2 versus A1, your incremental cash flow series are like this. Your incremental rate of return is at least MARR that you have established clearly by the calculation. Therefore, A2 is selected between A2 and A1. Then A2 is also selected between A2 and A4. And then A2 is also selected between A2 and A3. So overall, your A2 becomes the best alternative. Clear? Right? So this is essentially the IRR related technicalities. Method is very simple. When I have to introduce it formally, the language becomes a bit more cluttered. But I hope this example helps you understand what's actually happening, and it's very systematic and easy thing to do that way. Again, re-emphasizing, you have to make the equal life assumption, because otherwise the incremental cash flow series cannot be calculated. And since you have to calculate incremental rate of series, or whatever the rate of IR, basically incremental series, once you have the incremental rate or incremental series, doesn't matter which one are you going to use, PW or AW, because here you are not, AW is not helping you in reducing the number of cycles. The number of cycles still needed for you to calculate the incremental series. So therefore, the annual worth method has no specific advantage compared to the present worth method in this particular case, right? So if you get an objective question, 1 mark question, is AW always better than PW? You know what's the answer. Yes or no? Only 1%. Did you get the point that I'm trying to explain? So what we saw originally, when you are just comparing the alternatives directly, in AW you don't need to, you can avoid that repetition of cycles, right? But here, the method is constraining you to calculate the incremental cash flow series. And incremental cash flow series only can be calculated when you have taken the LCM already. So once you have calculated the incremental cash flow series, now whichever method you use doesn't make sense. It will not help you in solving the or simplifying your calculations further. It will be the same rigor. Okay? Yeah. So generally, again, my recommendation is IROR or IRR method in general is complicated, not 100% reliable in realistic cases. So if you have been given the freedom to choose the method of NPW, the present worth or the future worth or the annual worth analysis method that we have seen. Only and only when people are so adamant that they want IRR, then only go for this particular method. Otherwise, among the all possible method, this has least control that you can put in the analysis only, right? But the challenge is, a lot of people in the real world make decision on this number, annual return. How much annual return am I getting? How much is my rate of return that I am getting? That's such a intuitive number for you to follow. And therefore, a lot of people understand the number much better compared to whatever the present worth or future worth or annual worth. And therefore, you are kind of forced to represent the numbers in this manner. But this may be confusing in real world. The typical problem happens is when you are dealing with infrastructure projects of long service life, sometimes intermediate, you have to do very heavy maintenance. For example, after 5 years, you have to do a very heavy maintenance on road infrastructure. At that time, that extreme negative value can actually trigger multiple solutions of your IRR function. And that is out of your control. You can't really, so you need to plot it and then estimate what is the acceptable IRR for you in this case, right? So, yeah, so this is the so far the summary, and we will, one more method is remaining. We will start on this from tomorrow, but let me just give you a very brief introduction. This is essentially, so far we are talking about only in the pure money terms, but the real projects, the infrastructure projects, have also intangible benefits and intangible costs. For example, when you are creating a road, you are maybe cutting a lot of trees and that has a cost associated. And when you are creating a road, it's not only benefiting the users of the road, but it is also becoming more accessible, making it more accessible for people living around the road, right? Who are not necessarily the user, but maybe new businesses coming to them because of the now an improved road. So such kind of intangible benefits you can also quantify, and you should actually ideally be using that method also in a cost benefit kind of an analysis. So far we were dealing with purely monetary transactions, but I will just give you a brief overview of how to include this intangible benefits as well, and that method is called benefit to cost analysis or cost benefit analysis. And this is quite important for your project. Most likely you will be end up doing the best cost benefit analysis method. All right, so this is where we'll stop today.